This photograph, even though I haven't been able to put any animation on it, represents the Hubble bubble. Even though Erwin Hubble calls it uh, he calls it a balloon, inflating balloon. This is somewhat what it looks like. All these galaxies around this sphere in the center are outside the sphere. Relativity, uh, new information of people updating Einstein's theory say that all the galaxies and everything are inside this bubble. And since the bubble is expanding, there's more room inside the bubble. The only thing that contradicts is pressure and and the manipulation of energies from the galaxies that would be in it that change the physical form of a vacuum. What is a vacuum? Absent of matter, and in that case, absent of energy. In this photograph, with the galaxies outside this expansion, it shows how they're being pushed apart. The galaxies are being pushed away from each other as this thing inflates. It's somewhat invisible inside because it's the energy that this thing, this sphere, invisible sphere, at the center of our universe is causing expansion, is causing motion because of its momentum at a constant rate, which is faster than light. It's that much energy that this sphere has that it is accelerating a pathway for our galaxies. As this thing expands, it moves the galaxies, creating a movement in our universe. Without it, our galaxy would be just sitting there, and probably the universe would collapse because there's nothing holding them back from collapsing in on each other. So this sphere, invisible sphere, is created from the energy of all the galaxies. I don't know if it was, you would call it created from them, but if you look at the moon, high load, high tide, and low tide, its effect on Earth's ocean, think of how all the galaxies having toll on this midfield invisible anomaly. Uh, the energy we see comes from the moon to our oceans, predicting higher and low tides. Uh, you don't see it here either. You don't see that energy, but we can see its effect. The universe is expanding. How this was formed from the beginning is not beyond me. We look at the elements. Before there were galaxies in empty space, what existed? Cold. Cold. Cold is an element that changes form into water. Energy it causes an effect of raising the tide of that invisible uh, element. Actually, it'd be invisible because it would be transparent. So, so when we look at Isaac Newton's theory on how the planets stay in their position and orbit and rotate, it's that energy that forms this anomaly of the photograph I'm showing you here now. Without it, the universe would collapse. Uh, this is a theory that I've developed. I put out a new book. It's called Expanse Vacuum Gravity. It goes beyond uh, Hubble's observations. It reforms the idea of a subtle universe, as relativity predicts, and it shows a consistency, whatever, of a faster than light force. If we go back in Earth science, we discover that in in physics, in the evolution of energy, motors, generators, etc., they discovered that, and it was formatted from this, that it takes 2 pounds of energy to move a 1 pound mass. In other words, if you only have 1 pound of energy trying to push a 1 pound mass, it's not going to move. That's Einstein's relativity, a subtle universe. When you have momentum, you have you need 2 pounds of energy for that 1 pound mass. Now, when we convert that to the universe, how much energy do we need to push on all the galaxies relative to that theory that I've just mentioned? You need twice as much energy. So, my predictions that the universe is the force of this anomaly is 450,000 miles a second relative to squared energy. That much energy it takes to put the universe in motion and keep it in motion because this is at a constant. And it's expanding the uh, area between the galaxies in uniform motion. In other words, all the galaxies are there because that's the accepted position using Isaac Newton's uh, theory on position and gravity of all the planets in space. So uh, something could be born within that, which would affect the other galaxies, a newborn planet, sun, whatever, and change it just a little. The distance between the galaxies is enormous. So a newborn galaxy would be, it's logical, you know. But when we look at all these theories about newborn planets and stars and everything, they're all inside a galaxy that is already there. It's motion that keeps these galaxies alive, let's say. Without them, just think of it, it would be, everything would burn up or freeze. Those are the two main elements of our space. How much heat there is, I think it's 4K, and how cold it can get. There's more cold in the universe than there is heat or suns or warmth from all the other matter that exists. This is an explanation of my new expanse theory. It takes twice as much energy. That means the force that causes to put our universe in motion is twice as much that Einstein predicts to be the speed of light. In Einstein's theory, 1 pound of energy will advocate for 1 pound of mass. But that's not how it works. That means there would be no movement in our universe, or it would collapse. Just think about it, it would collapse because there's nothing to keep it from collapsing. I hope you like my videos. I have a new book coming out. It's called EVG, Expanse Vacuum Gravity, putting the universe in motion. Thank you. My books are on Amazon. Thank you.
Hey there, science enthusiasts.
Fascinating concepts of space curvature and space acceleration. These ideas might sound complex, but trust me, they're incredibly intriguing and can change the way you think about the universe. You might have heard that massive objects like planets and stars bend the fabric of space, creating what we know as space curvature. This bending is what gives us the force we experience as gravity. This idea comes from Einstein's theory of general relativity, which beautifully explains how gravity works. Einstein revolutionized our understanding of gravity by showing that it's not just a force between masses, but a result of the curvature of space-time itself. Picture a heavy ball on a trampoline causing a dip. That's space curvature. The heavier the object, the deeper the dip, and the stronger the gravitational pull. But wait, there's another intriguing concept, space acceleration. This idea adds another layer to our understanding of how objects move through the cosmos. Imagine you're in a rocket, traveling through space. You might think you're moving in a straight line, but according to general relativity, the space around you is curved by nearby massive objects. So, even though the rocket moves in what seems like a straight line, the curved space makes it feel like you're curving around these massive objects, much like a car turning on a winding road. This is a crucial point because it shows how our perception of movement is influenced by the curvature of space itself. Now let's tweak that perspective. Instead of just thinking about space curving around massive objects, let's consider the idea that space itself can have an acceleration rate. Imagine space expanding, causing its position to change over time. This expansion isn't just a passive stretching, but an active process that can influence how objects move. As space expands, it changes the positions of objects within it. This means that as you travel through space, you're not just curving due to gravity. You're also accelerating because space itself is changing. This concept is like being in a car that not only turns but also speeds up. The acceleration you feel isn't just from the car's engine, but also from the changing road beneath you. Think of it like this. When you're in a car, you feel the momentum as you accelerate. Similarly, as space expands, it changes the positions of objects within it, giving a sense of acceleration. This acceleration isn't from space curvature, but from space itself expanding. It's a dynamic process that adds a new dimension to our understanding of movement in the universe. This acceleration isn't from space curvature, but from space itself expanding. It's a dynamic process that adds a new dimension to our understanding of movement in the universe. And here's a cool analogy. Think about magnetism between two similar masses, like repelling magnets. This creates an invisible push force. Magnetism between two similar masses, like repelling magnets, creates an invisible push force. This is similar to how energy and electricity work. You don't see the force, but you can feel its effect. You don't see the force, but you can feel its effect. In the same way, space acceleration is an invisible force impacting how objects move. In the same way, space acceleration is an invisible force impacting how objects move. It's a subtle but powerful influence that shapes the dynamics of our universe. So, to sum up, while space curvature explains gravity through the bending of space by massive objects, space acceleration provides a different perspective. It suggests that the expansion of space itself causes changes in position and momentum. This dual understanding of space curvature and space acceleration gives us a richer, more nuanced view of the cosmos. Keep exploring, stay curious, and never stop questioning the universe. The more we learn, the more we realize how much there is yet to discover. If you enjoyed this explanation, hit that like button, subscribe, and share it with your fellow science geeks. Thanks for watching. Your support helps us bring more fascinating content to you. Catch you in the next video. Until then, keep looking up and wondering about the mysteries of the universe.